sections 8.1 and 8.2 on systems of equations. Section 8.1 was on solving a system of equation in two variables by graphing. System of equation or system of inequalities is two or more equations or inequalities in several variables that are considered simultaneously. In the first graph on the left, you notice that two lines are graphed on one coordinate plane. The lines may intersect. Two lines graphed on a coordinate plane may also be parallel, or the lines may coincide, meaning the two lines are on top of one another. It's the same line. It looks like one line graphed. Here are some examples. So if we're asked to graph two equations on a coordinate plane, we would need to know our two equations, and then we can plug in or replace our variables for x, substitute to solve and get a value for y, get at least 3 points to plot on the graph, connect those 3 points to make a line, and do the same thing for our second equation, and then we'd have two lines that are graphed. And we can see whether those lines intersect, are parallel, or if they are the same line. And in this case, the two lines intersect. We can check our work and make sure where those two lines intersect. In this case, the two lines intersect at -1 on the x-axis and down to -3 on the y-axis. So just to make sure that that point would actually be a solution of both equations, we would need to replace x in our formulas with -1 and y in those same equations with -3 and make sure that our solutions work. And in this case, the solution is said to be consistent when it does work. So here is the second example, solve by graphing. Solve the system by graphing. And we replace x with 2, 1, and 0 in both equations. Graph those points. We can see that the lines are parallel. They do not intersect. So in this case, there is no solution. There is no point at which these two graphs intersect at one similar point. So in this case, this system, these two equations, have no solutions, and therefore they are called inconsistent. This is an inconsistent system. Our third example shows that when we graph our two lines, the lines are the same. So there would be an infinite number of solutions because every single point on this line coincides with the other line. So in this system, we call it a dependent system when we have infinite number of solutions. Here is an example. Walter and Barbara need some plumbing repairs done at their house. They call two companies for estimates of the work that needs done. Robert's Plumbing and Heating charges $40 for a house call and $35 for labor an hour. And Instant Plumbing Repairs charges $70 for a house call and then $25 per hour for labor. Create a cost equation for each company where y is the total cost of plumbing repairs and x is the number of hours of labor. Write the system of equations. Then graph the two equations using the variables 0, 3, and 6. Determine from the graph how many hours of plumbing repairs would be required for the two companies to charge the same. Determine from the graph which company charges less if the estimated amount of time is 4 hours. So first we'll write our equations. The first one would give us y equals 40 plus 35 times x. X is the number of hours, y is the total cost. And the second place charges $70 fee up front and $25 per hour. So at what point would the cost be the same? And we can find that as to if we graph these two lines, do they intersect? So we'll fill in a table of values, 0, 3, and 6, find our value of y, graph our two lines and figure out where they intersect. They intersect at 3, 145. So therefore, the two companies will charge the same if 3 hours of plumbing repairs are required. After that, what do we notice? The cost is actually cheaper on the red line than it would be on the blue line after you meet that amount of 3 hours. So even though you are paying more up front, you'd be paying less if your work would take longer than 3 hours, and you'd want to go with the red group, which is our second instant plumbing repairs. And if your work would take less than 3 hours, we would want to pay less amount up front and go with our blue group or our Roberts plumbing. So determine which company charges less if the amount of time is 4 hours. And at the 4 hours, it would be our red line. So thus, the cost would be less if Walter and Barbara used instant plumbing repairs for 4 hours of work. So seeing a real-life application as to why we would want to graph 2 lines to see whether they intersect or not, or whether their cost is the same. This is a real-life scenario that you may encounter. Section 8.2, we're going to solve system of equations, but we're going to use a different method other than graphing. We're going to look at 2 variables by using the substitution method. So what is the substitution method? So we're going to solve one of the 2 equations for one variable and then replace that variable in for the other equation to solve and find that value, and then we can check our solution to verify the results. So let's take a look at our first example here. We have 2 equations. We're going to solve the first one for y, and then we will replace this 2x minus 13 in for y in our second equation. Right, that came from here, second equation, and solve for x. So we get x equals 5. To check that, we will then replace x equals 5 into our first equation and solve for y to see if we end up with the same value, right? So we got x was 5 and y was negative 3. So our solution is x is 5, comma, y was negative 3. There's our 5, comma, negative 3. We can check the solution in both the original equations just to verify it works for both of them. If we replace x with 5 and y with negative 3 in both of our equations, it does work. We get a statement that is true. These are equal. These are equal too. We'll try that one more time. We can find the solution and check our answer. So we'll solve for one of our values. In this case, find the solution, check your answer, clear the fractions from the equation first. It might be helpful. So we can multiply everything by 3, 3, and 3. That would give us negative 9 over here. Now it might be a little bit easier to work with so that we don't have fractions anymore. We can solve for y by subtracting 2x, replace that in for y in our second equation, and simplify. Simplify, solving for x. We get x equals negative 4. Replace that in for x in our second equation. We get negative 4, negative 1. And then replace negative 4, negative 1 in for both original equations and make sure that our solutions work, and they do. That concludes 8.2.